Mutual information. Mutual information tells you how close are two random variables to being independent. We already learned about what is mutual independence of random variables. And in case you want to measure how independent are two random variables, this is where mutual information comes in. So the reason why we are learning this right after KL divergence is that mutual information is an application of KL divergence. You use KL divergence in order to identify mutual information. If there are, let's say, two random variables, x and y, we already know that if they are independent, how can you identify if they are independent? P of xy will be same as P of x into P of y. So let us first take the joint distribution. Joint distribution of two sets of variables x and y, it can be written as P of xy, that is the probability of x and y occurring together, that is the joint probability. So let us say this is a distribution, the probability distribution, the joint distribution of x and y, where x and y are random variables. If they are not independent, what will happen? And if they are independent, what will happen? If they are independent, in that case, P of xy, this will be same as P of x into P of y. This you already know. From our previous lectures, you know that if two random variables x and y are independent, then P of xy would be same as P of x into P of y. What if they are not independent? Till this point, you just know that you will get an inequality. If they are not independent, P of xy would not be equal to P of x into P of y. But how can you quantify this value? How would you know how close are these two random variables x and y to being independent? So in applications, we may actually need to know whether they are close to being independent or are they far from being independent. In that case, in order to get a quantification, you use mutual information. So let us understand mutual information. We denote mutual information by I. So I of x, y. This is mutual information. This can be found as KL divergence between the two distributions. That is, one is you have P of xy. At one end, you have P of xy. On the other end, you have P of x into P of y. So you know that in case x and y are independent, P of xy, this should be same as P of x into P of y. These two are two different probability distributions. Two probability distributions, how can you compare two probability distributions? It is using KL divergence. So in order to identify mutual information, what do? You see the KL divergence between the first distribution and the second distribution. In case both the distributions are identical, that means P of xy equal to P of x into P of y. In that case, KL divergence will be 0 and they will be independent. That is, x and y will be independent. P of xy and P of x into P of y. These two values will be identical. In case KL divergence is a positive value greater than 0, then these two distributions would not be independent, but these two, in the case the distribution of x and y, so x and y would not be independent, won't be mutually independent, but you will be able to understand how close are they to get to being independent. So KL divergence between P of xy and P of x into P of y. This is what you want to identify. This value will tell you whether x and y are independent, and if not independent, how close are x and y to being independent. So what is the formula for KL divergence? Let us say there is P and Q. Then KL divergence between P and Q, this can be written as, how do you write this? It is integration over all the values of x, P of x into log of P of x by Q of x. This is how we learnt about KL divergence, right? So this equation, if you use here, what will you get? KL divergence between P of xy and P of x into P of y. Here these are continuous random variables. So instead of summation, you will use integral. Integral of this dx. This is how you write it. So here you have two random variables, x and y. So how do you deal with this? You will have a double integral. That is, okay, I can write it as double integral of P of xy, that is the first term, into log of, what is the second term? P of x by q of x. In that, here you are comparing P of xy and P of x into P of y. So this will be P of xy divided by P of x into P of y dx dy, right? This is how it will be. So the KL divergence between P of xy and P of x into P of y can be written as double integral of P of xy log of P of xy divided by P of x into P of y dx dy. This is how you find the mutual information between two random variables x and y. What does this value signify? If the mutual information of x and y, if this turns out to be 0, if this turns out to be 0, that means x and y, they are independent. So independence you can anyway find simply by equating P of xy to P of x into P of y. But what if they are not independent? In that case, in order to quantify, you need this mutual information. It will be, if this is greater than 0, in that case, whatever is the value that you get, that value will determine how close are x and y to being independent. In case the mutual information is very close to 0, if it is a very small value, in that case, you can say x and y are almost independent. They are very close to being independent. So in order to quantify this, you use mutual information. One more thing is that mutual information can be calculated from entropy. We had seen that information is always denoted by entropy, and this mutual information I of xy, this can also be calculated as entropy of x minus entropy of x given y. This is another way of calculating mutual information. That is, either you can calculate using this formula, or another way is this entropy of x minus entropy of x given y. This can also be calculated, or it is same as entropy of y minus entropy of y given x. So entropy of x minus entropy of x given y and entropy of y minus entropy of y given x, these are one and the same. So this is another way of calculating mutual information. So mutual information will tell you how close are two random variables x and y to being independent.